So today we are moving on to the last part of module 4, combinational circuits. So what is left out now is only demultiplexers, and today we are going to see what a demultiplexer is. But if you see, demultiplexer is just the opposite of a multiplexer. So by now we all know what a multiplexer is. Now let's go into the details of demultiplexer. So what's a demultiplexer? It is also a combinational logic circuit, but it is going to perform the reverse operation of a multiplexer. Okay, so in case of a multiplexer, it was 2:1 mux we called, in the sense two inputs, but only one input will be selected at the output. Similarly, 4:1 mux, in the sense there will be four inputs, and out of the four input, one input will be selected at the output. Hence, it is called 4:1 mux. In case of a demultiplexer, we are just going to say it the reverse way. So, the types of the demultiplexers are 1 to 2, 1 to 4, 1 to 8, 1 to 16, 1 to 32, like that. What is the meaning of it? One particular input, and we will have four different outputs. Right? Let's see in detail what exactly it is. So basically, if you see, a demultiplexer means one to many. It is a circuit with one input and many output. So the way we had in multiplexer a select signal, here also we are expected to have a select signal, which is nothing but a control signal that can steer any input to the output. So what is it going to do? It's going to it's a process of taking an information from one input and transmitting the same information over one of the several outputs. There will be many outputs connected, but this single input will be chosen in such a way that it will go into any one of the output, and that is done by use of a select line. So if you can remember, this is what we have seen in the previous lecture, which is nothing but a multiplexer, which is a 4:1 mux. What is showing here? There are four inputs, hence it is called as a 4:1 mux, right? This is a 4:1 mux. So in order to choose one of the four inputs, 2 to the power 2 is equal to 4. So how many select lines are required? 2 select lines are required, and that's what is taken here. If it is a 8:1 mux, what will happen? So what is 8? 2 raised to the power 3 is equal to 8. So how many select lines are required? Select lines required are 3. That's the meaning of it. Yeah. So now what is a demultiplexer? So demultiplexer is only one input. What is demultiplexer? It's going to have only one input and four outputs. And this particular single input, to which particular output line out of these four output lines it has to come out, is decided by the select lines. Right? So that's the difference between a demultiplexer and a multiplexer. So in this case of a multiplexer, any one of the input will come out as an output that was decided by the select line. In this case of a demultiplexer, the single input that I have will come out as an output in any one of the output. Yeah, that is transmitted in only one of the output. That is a demultiplexer. So let us go ahead with a 1:2 demultiplexer. So as the name itself says, anyway we know very well that for a demultiplexer input will be only one. All the time input will be one. In case of a multiplexer, the output is always a 1. Right? So we are talking about a demultiplexer. So input is 1, but it is a 1:2 demultiplexer. So there are two outputs. Yeah. The first one talks about how many inputs, and the next one talks about how many outputs. So it is single input and two outputs. If there are two outputs, then 2 raised to the power 1 is 2, right? And so how many select lines are required? There is only one select line that is required. If the select line is a 0, the point is, if the select line is 0, A input will come out as at Y0 output, But if the select input is 1, this input will come out here as an output. Which line has it come? So if you look at the truth table, select lines can be either a 0 or a 1 alone. So when it is a 0, y0 will get the input as it is, and when it is 1, y1 will get the output. So how do we write the equation? So every time you have to remember, equations are to be written for every output that we have. There are two outputs there, so there will be two equations. There are two outputs, hence there will be two equations, right? So how do we do that? So we are writing for y0. So y0 के लिए क्या है? Y0 is the select line is 0. So we mark it as S0 dash. That is S0 bar. And y1, y0 is a, yeah, so that's what a is given. So s0 dash into whatever is a, input a is taken here. Similarly for y1, s0, which is a 1, s0 means select line is a 1, so it is s0, there is no bar, into the input a. That's how we have to write it as an equation. So after having written this equation, we are expected to draw the circuit diagram. So there are how many inputs? There are only two inputs. One of them is A, another one is S0. So A and S0 is taken. In case of Y0, it is S0 bar, and hence S0 is given to a naught. So this becomes S0 bar, S bar. So S bar into A. So Y0 is equal to S bar into A. What will happen to Y1? Y1 will be S into A, right? So this is the equation of a 1:2 demultiplexer. Now let us talk about a 1:4 demultiplexer. As I said, input is only 1, but output is 4. So how many select lines are required? We have to see. 2 raised to the power 2 is equal to this 4. Yeah, so how many raised? 2. So we require 2 select lines, and hence we have used 2 select lines here. Data input is only 1, but then output are 4. So this input, into which line should it come out as an output is the case. So if you see, data input is the same, that is D. Select inputs are 2, which is nothing but a 0 0, 0 1, 1 0 and a 1 1 combination, out of which if you see, for a 0 0, we are considering that only at y0 the output will come. Similarly for 0 1, only at y1 the output will be available. In this particular case, the third case, y2 it will be available, and in the fourth case it will be available at y3. So accordingly we have to write the equation. There are four outputs, so we need to have 4 output equations. Y0 is equal to, what is y0? Y0 is nothing but select line combination is S1 bar into S0 bar into the D. Similarly, y1 is equal to S1 bar into S0 into D. Then y2 is equal to S1 into S0 bar into D. Then the last one being S1 into S0 into D. So these are the 4 equations. Once we get the equations, so based on the equations, we get to know what are the inputs, what are the outputs. So how many inputs are there? S0, S1 and D. There are 3 input combinations and 4 output. So in order to make it as a Y0, from these lines, we are taking it as S1 bar and S2 bar. So S1 is given to a NOT gate to make it as S1 bar, and S2 is given to a NOT gate to make it as an S2 bar. And hence if you see, this is getting an input of S2 bar, this is getting an input of S1 bar. Here S1, S2 is nothing but we can consider this as S0. Yeah, so let us consider this as an S0. Yeah, so S1 bar into S0 bar into D. So if you see, all these 3 goes as an input, which is your Y0. Similarly, in case of an Y1, it is nothing but S1 bar, S0 directly given. See, S1 bar given, S0 given, and then D is given. Likewise for Y2 and Y3 also, these equations are taken into consideration. So if you move on with the 1:8 demultiplexer, the difference is it is 1 input and 8 outputs. So when will we get an 8? 2 raised to the power 3 is your 8. So how many select lines it should have? It should have 3 select lines. 1 input, 8 outputs. Now we can form easily the truth table. So in order to make 3 select lines, what are the possible combinations? 0, 0, 0, 0, 0, 1, these combinations, yeah. So that's what is written here. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1, the maximum combination. And so if you see, it will always be in this diagonal form. It is because our rest of the things are 0 and it should be available only for one case, and hence we have written it like this. And similar way we need to form the equation and draw the circuit. We will have 8 equations, so there should be 8 outputs here. There are 4 inputs, we have considered 4 inputs. Yeah, so we know what are the applications of a multiplexer. Like we have come across the applications already. It is used in a communication system. Yeah, so it can be used in any communication network. How the efficiency also can be increased considerably using a multiplexer. This example I have shown you in the previous slide. Instead of taking too many connections in a microcontroller, we can minimum the number of pins by making the multiplexer. This example we have already seen. Yeah, so multiplexer allows the process of transmitting different type of data such as audio, video at the same. I'm just trying to recollect the previous lecture here about the applications of a multiplexer. So what are the applications of a demultiplexer? It is the same. A communication system uses multiplexer to carry multiple things, right? So what will happen? The demultiplexer will receive the output signals of the multiplexer and converts them. So one end you will have a multiplexer, the other end you will have a demultiplexer. So whatever you are trying to do with the multiplexer, those signals are received by the demultiplexer and they are converted back to the original form. Yeah. So if it is 4 input which is converted to 1, this 1 is given as an input to the demultiplexer and again it converts back to a 4. Yeah. So it is to be used back to back in order to get back the original. So the multiplexer and demultiplexer work together to carry out the process of transmission and reception of data in any communication systems. So these are the applications of a multiplexer and a demultiplexer.